Hello and welcome back to the second episode of Kerbal Space Exploration. Today we are sending our first communication satellites into orbit. We will have two polar satellites that will orbit over the North and South Pole. This will give us good communication to the moon. And we will probably send one up in orbit around Kerbin's equator. In due course we will probably do some geosynchronous satellites too, but for now this will go for 450 kilometers above Kerbin, which is a good enough distance to have good communication to the moon. Now this rocket is built with KW rocketry pack, and the communication satellite is inside these fairings. We just went over to our main solid booster, which will take us up to about 20,000 kilometers. And after that we have a small rocket on top, liquid fuel rocket, that will do our orbital, our circularization turn, and it will bring us up to 450,000 meters or 450 kilometers. So I'm using the mechanical jib to do this because we're going to send up quite a few rockets, and I'm lazy that way and it's not particularly difficult to do it. So this is an easy enough task that mechanical jib can do it. And another thing that's good with using mechanical jib is that I can free up my hands and mind and concentrate on talking. Now this rocket actually I started building this rocket to build something that represented the Falcon 1 rocket to SpaceX, but I didn't have enough power in the solid booster to bring this up more than 100 kilometers, which I guess is probably somewhat close to what the Falcon 1 is supposed to be. I haven't read too much about the Falcon 1, but it's supposed to bring things into low Earth orbit, and we are going for a little higher orbit, so I put on the 4 solid booster rockets on the bottom, as you saw in this launch. Now mechanical jib takes care of everything right now. I said how high I want to go, what heading, and some staging and editing paths and stuff. But you can see that my rocket weighed at launch about 77 tons, and it's about 6 tons left of that rocket now. So we lost quite a lot of weight on our travel. And we are now exiting the atmosphere, so we can open the flares or shoot away the flares and take a look at our probe. So this is my communication probe. It has a couple of antennas and a satellite dish. It has 6 batteries, 3 on each side, and we have, I think, about 6 of the radioisotope power supplies. So this probe does not have any solar panels, mainly because it's going to be used on the dark and light side of Earth, and we don't want to lose power when we're on the dark side. So why do I need all this power? Well, we are using the electrical propulsion system with this probe, and that means we need electricity, a lot of electricity, to power this. And we don't have enough electricity to use this at full throttle, but we can go close to half throttle, and this also makes sure we have plenty of electricity for the next couple of years to use this satellite. I think they are supposed to last a couple of years. I'm not 100% sure how long they last. I'll have to check that for later. But it's pretty simple design. It's the electric propulsion, 2 xenon tanks, and the batteries and power supplies. And it weighs about 1 ton. So Mechanical Jeb has gotten us into orbit, and we're now using the Orbital operations tool to change our altitude, or APWAPS actually, up to 450 kilometers. And I'm using the vessel information to see how much velocity I have left in the tanks, because seeing this I would think I had not enough fuel to do this operations at all. Now I kind of like working with Mechanical Jeb because it helps you with a lot of the boring stuff, we can say, or it helps you with some of the calculations and work. But the feature I like the most is the warp function, where you can say where you want to warp to. And I actually said wrong now, so we're warping all the way around and back again, and we have to warp to APWAPS. So I'm getting my beloved lag when I screen record, and I have ordered a new screen record device. As of now I'm using screen recorder software, and for some reason it sometimes just freezes all up. So that's APWAPS, and let's do the circularization. And Mechanical Jeb will do this for us too. Now after this, the probe will detach from the rocket, and we will send the rocket back to Kerbal. So we have to leave some fuel for that. But that should be plenty of fuel in here now to do complete retrograde burn. Oh, that was not too good for our satellite. I hope it survived that. So let's see. We are a little bit out of control, but we can bring that back. So 450, and that slingshot us quite a bit out. That was bad of me. I should have waited until we had a little bit more distance from the satellite, but it looks like we can fix it up here and test the engines. So the probe does not have Mechanical Jeb, it just was the launch vehicle and rocket that had Mechanical Jeb, because this probe is so small and we don't need Mechanical Jeb for its operations. For most part it's just going to circle the Earth or Kerbal, which I cannot find. There is Kerbal. So let's see how our orbit is getting. Let's bring that down even a bit more. Let's take it down too, so we get a circular orbit. Just doing the small changes here, so we'll get circularized. And let's do a last burn upwards and getting it very close. So that is more than good enough. 300 meters in difference. That will work. So my plan with the communication satellites is that this satellite will be able to talk to people on the moon when it's on this side and on this side of Kerbal. But because it will lose communication when the satellite goes on this side of Kerbal and the moon is on that side, or opposite, we will send up one more that will go at a 90-degree angle to this rocket. We'll probably have to do a little bit more maneuvering to get that to work. So let's go back to Space Center and send up the next rocket. So let's look at the map. Where is about midway? We're pretty close to where we need to be to do the launch, but I want to be very close. I think that's probably good, and we'll do mechanical jab for this to engage. And with this rocket, it's very important to remember the RCS, because that's the control. That's what's doing all the controls at launch, and as long as we use the solid fuel rockets. And yes, as I said, I have ordered a new screen recorder. It's going to be an external device that goes to one of my other computers and will free up a lot of memory and hard disk and CPU time on my computer. So hopefully that will make you guys see what I see when I play the game without the screen recorder, because usually I only get lag if I play with very big stations. So yes, let's see how our orbit is going. I think it will be pretty close to a 90-degree angle. I want it to be a 90-degree angle right here across the North and South Pole, and I think that should give us plenty of communication possibilities to the moon. And we should probably send a couple of satellites to the moon too in the same manner. We'll have to build a rocket to do that, because these, well, we can fly there with the probes because they have enough delta V in the probes to do an escape velocity, but the probe will use about 2 hours to get there. So maybe I will send one into the solar system and show you a time lapse of that. And we're getting a beautiful view of the moon in the background as we do the launch. And I'm actually pretty satisfied of how well this launch stage worked. It's pretty simple, and it was just something I did for fun, but ended up being an easy and efficient way of getting my probe into orbit. So let's take up the vessel information, and we can see how much delta V we have in the atmosphere and in a vacuum. And then you can see here that the time, or the velocity in the probe, is 3,487 meters per second, which is very much, actually. You could get pretty far off that, but as you see, emptying all that velocity will take 3 hours and 12 minutes, so you'll have to be patient. Even on full time warp, that will take almost an hour, about 50 minutes I guess. So maybe I'll send out a probe into the solar system and make it like a survey probe or something, but I don't think I will record the whole trip and make you watch the whole 45 minutes, but we could make a time lapse out of that. So let's get rid of the fairings, that extra weight, engage all the communication possibilities and the antenna and the satellite dish, and just let it burn until we get to our apoapse and periapse. So it looks like I was really lucky on this one. 90.5, it should be 90.0, so that 0.5 we can fix pretty easily. That was less than I thought. I was hoping for nothing more than plus minus 5 degrees. But 90 is a good number. That I like that. And warping to our apoapse. And this probe, yes, there it crashed into the ground. That was about time. So I think for the next episode we are going... I was thinking of doing the whole Apollo mission style with practices around Kerbal and stuff, but I've been waiting a long time to start this series now, and I have so many plans and ideas, and I almost built all the spacecrafts already. So I think we will do a rendezvous test in orbit and go to the moon and see if everything works as it should, and if everything works and we have enough fuel to go back and home, then in the next episode after that we would do the landing itself. So just doing as I did earlier, bringing everything up to 450, preparing to warp to the apoapse. So this time I remembered to push apoapse, so we don't need to wait for me to spin around Kerbal a couple of times. And let's circularize. And while it is circularizing, I can tell you that the mechanical jeb also has autopilot to the moon and Minmus, and you can also use it to get to other planets if you want to do that. Use it for that. So our orbits are pretty close, hopefully not that close that they will hit each other after a while, but I think it should be a couple of 100 meters difference. Will be pretty big with these small probes. So let's get rid of mechanical jab and let's change that last point of a degree. So 90, yay, right there. That looks perfect, and that's about 15 meters delta V. So actually we will do that with the probe, and we'll send this part home again. And this time I will not make the same mistake as last time. Being very careful here now. Getting it away from the probe. And let's take it down. Now, mechanical jab also has a landing autopilot, but since we're not landing, it's no use to use that. So, oh, we were still close enough to go over to the probe. Perfect. Let's find the maneuver marker. And where is it? Is it gone? Yes, it's gone. Maybe it followed the rocket, I don't know. But let's set it as a target again. I think it did not like my little switcheroo of crafts there, I guess. So back to 90. Perfect. 14 meters per second in 32 minutes. And let's just check our apoapse and periapse after this, so we don't change it too much. Nope, that looks very good. So let's warp to the top, and this looks pretty good. I think it will be pretty cool when we get more satellites around Kerbal, more communication satellites. It will look pretty cool, like with a dome effect over it. So how much time do we need for 14 minutes delta V? About a minute, it says. So let's just get a little bit closer. That was a little too close, but never mind, it will work. And let's time warp or physics warp these 45 seconds. So just getting it absolutely perfect. And we're going to be a little bit difficult here in getting it very perfect, because these are going to stay up here for the next couple of years. So why not make it perfect? There we go. So I guess I want to... What can we say that the satellite dish is for? Should it be for sending signals back to Kerbal, or should it phase out into space? Please give me feedback on what you think we should use the satellite dish for and what way they should be facing. So I think that will be it for today, and we will send up the next missions of going to the moon in a couple of days. See you guys later, and please like and subscribe and give me some feedback. Wearing Storm signing off.